Okay, so get this. This research paper's got this idea that instead of just making AI smarter by making their brains bigger, we should be teaching them to actually think better.
Hold on there, before we get into the meat and potatoes. So to speak, let's say hello to our listeners first. Welcome to this installment of Linkffiti's Deep Dive. We hope that you enjoy it.
A pretty wild paper, huh? And it all comes down to this thing they call test time scaling, right? It's like giving an AI, scratch paper and saying, okay, here's the problem. Take your time, show all your work, and really think it through step by step. It's a really interesting challenge to that traditional idea that you just increase the model size, right? Make it bigger and bigger.
Right, just keep adding more stuff.
Yeah. And this is about how effectively it uses what it knows as opposed to just how much it knows. So instead of just cramming more information into their AI heads, we're actually teaching it to think strategically. But how do we even start to understand how an AI thinks? I mean, we can't really open up its brain, right?
Well, that's where these reasoning traces come in. Okay, and so these are sort of step-by-step explanations of what the AI is doing.
So it's like we can kind of peek into the AI's thought processes.
Exactly.
Kind of look over its shoulder as it's working.
Yeah, like you said, it's scratch paper.
You can see what it's thinking. I mean, I'm wondering though, are longer reasoning traces always better? I mean, couldn't it be a problem for AIs to overthink?
Well, that's a great question, and it's something that the researchers actually address head-on in this paper. Okay? It's not just the case that more thinking equals better results.
Right, more thinking is not always good.
Yeah, there's kind of like a sweet spot there, a balance between giving the AI enough time and then preventing it from going down these rabbit holes of just overthinking.
It makes sense. I mean, even we humans, we overthink all the time. But before we jump into that, I want to talk a little bit about how they're even testing this. The researchers put together this really unique data set called S1K, right? They describe it as high quality, diverse, and difficult.
Yeah, sounds like fun.
Sounds pretty fun. What makes this data set so special?
Well, one thing is it's really diverse in terms of where the questions are coming from. Okay, so they're drawing from all sorts of things like Stanford PhD qualifying exams, quantitative trading interview questions, and they even have problems from the American Invitational Mathematics exam. And even from these Olympiads, those really tough academic competitions.
Oh, yeah.
So there's a real range of different types of questions.
Wait, is this where that crazy human versus star fact comes in?
That's right. So, one of the questions comes from the astronomy section of one of the Olympiads, and it asks what the sun's temperature would be if it produced the same amount of power per unit volume as a human.
I don't even know where to start with that.
It's a tough one. It's a real brain teaser.
I'm already intimidated. But seriously, why go through all this trouble to create this really challenging data set?
Well, the idea is they wanted to really push the limits of AI reasoning. They wanted to see, if you give these systems problems that even really advanced language models struggle with, how do they perform?
Right. So it's not about how much the AI knows. It's about how well they can actually use that knowledge.
Exactly.
When it really matters, right?
Interesting. Yeah. So that's sort of the testing ground. And then, okay, the other piece of this is the actual different approaches to this test time scale. Right?
And so they look at two main things. They look at sequential thinking and then parallel thinking.
Okay. What's the difference?
So you can think of it this way, if you're solving a complicated math equation, you might sort of tackle it step by step. Wow. Right. Building on what you did previously, right?
That's sequential thinking.
Makes sense. But if you're brainstorming ideas for a project, you might sort of come up with a bunch of different solutions independently. Okay.
And then pick the best one.
That's more like parallel thinking.
So it's like sequential thinking is kind of like a very laser-focused approach, and parallel is more like you just throw everything at the wall and see what sticks.
Yeah, it's a more sort of expansive, right, kind of creative brainstorming. kind of approach.
Gosh. So they look at both of those, but the paper really focuses in on this idea of budget forcing.
That sounds kind of ominous, budget forcing. What is that?
Yeah, it does sound a little bit dramatic. But basically what budget forcing is it's about setting limits on the AI's thinking process.
Okay.
Right. So preventing it from going into these endless loops or just kind of overthinking a problem.
So it's like we're giving the AI a certain amount of time to kind of solve the puzzle.
Exactly. And so, instead of letting it just sort of run wild with its thoughts, we're imposing some constraints on it to see how that affects its performance.
Okay. But how do they actually implement this? Do they cut the power to the AI when time's up?
Not quite. No. There's different ways they do it. One is they set a hard limit on what are called thinking tokens that the AI can use. And these tokens, you can think of them as kind of like the Lego bricks of the AI's thought process.
Interesting.
Right? So each token represents a piece of information or like a step in its reasoning. So by limiting the number of tokens, they're essentially saying, you've got this many Lego bricks.
To build your spaceship, right? You can't just have unlimited Lego bricks.
Exactly. You got to work with what you got.
That's pretty clever.
Yeah, it is. And they also experimented with broader time-based instructions, right? They'd say things like think for a short amount of time or think for a long amount of time.
Which seems kind of vague. Would the AI even understand what that means?
You'd think it wouldn't, but it seems like to some degree it did. Okay. They found that prompting the AI to think longer generally did result in longer reasoning traces. But the question is whether those longer traces actually led to better solutions. And that's something we can dig into a bit more.
Yeah, that's what I want to know.
So stay tuned. It did, and it led to some pretty interesting results. But like a lot of things in AI, it's not just a simple answer. Longer thinking time doesn't always automatically mean a better result, right? Yeah, it's like that saying, measure twice, cut once.
Sometimes taking a little extra time, think things through can prevent you from making a really dumb mistake, right?
But sometimes you can overthink things too, and, go down a rabbit hole.
Exactly, and that's why it gets really tricky trying to figure out, where that line is, where the benefits of budget forcing kind of stop.
Yeah, what are the limitations?
Yeah, and one of the big limitations is the AI's context window, which is basically its short-term memory.
Oh, okay, so like our own working memory.
We can only hold so much in our minds at once.
Exactly. And so the AI, no matter how much time you give it, it can only really hold so much information in its mind at a time.
Right, like it's trying to work on this giant puzzle, but it can only see a few pieces at once.
That's a great way to think about it.
And that highlights, how complex this all is. It's not just about finding one weird trick to make AI smarter, right? There's no silver bullet.
Yeah. It's about understanding how all these different factors work together. The thinking time, the memory capacity, and then the actual complexity of the problem itself.
Yeah. It's like we're trying to tune this really complicated machine. All these different settings and dials to try to get it to run smoothly.
Exactly. Now, another really fascinating thing they found was this thing about rejection sampling.
Yeah. Remember how we were talking about how sometimes shorter reasoning traces actually led to more accurate answers?
Yeah. It seemed kind of backwards, right? Like the AI was thinking less and getting better results.
It did, and it's kind of counterintuitive.
But the researchers wanted to understand why that was happening. So they were like, okay, why is thinking less sometimes times better?
Yeah, and so they looked at all these cases where the AI got the right answer with a shorter reasoning trace, but then got it wrong when it had more time. And what did they find?
Well, it seems like when the AI has a limited budget, so to speak, it's forced to be more efficient with its thinking.
Right, it can't waste time.
Exactly, it has to get straight to the point. Okay, but when it has more time to think, sometimes it can get sidetracked or start backtracking, and that actually leads to more errors. So, it's like when we're under pressure, we sometimes come up with our best ideas, but if we have too much time, we can overthink things and mess it all up.
That's a really good analogy.
Yeah, makes sense. And it raises some really interesting questions about thinking itself.
Yeah, for both AIs and humans.
Exactly. Like, what can we learn from AI? If we can train AI to think more strategically, can we learn to do that ourselves?
Yeah, that's a cool idea.
Like, if AI can avoid these thinking traps, maybe we can too.
Exactly. Alright, so now let's switch gears a bit and talk about that other approach to test time scaling.
Parallel thinking. Remember how we talked about it being kind of like brainstorming multiple ideas at once?
So the paper looks at two main ways to do parallel scaling: majority voting and tree search.
Okay, what's majority voting?
So majority voting, you can think of it as kind of like a democratic poll of different AI agents. The AI generates multiple solutions independently, and then the answer that shows up the most is the one that's selected.
So it's like the wisdom of the crowds, but with AI.
That's kind of cool.
Yeah. And then tree search is a little more complicated.
Okay, how so?
It involves evaluating the AI's reasoning process at each step using a separate reward model.
So it's like having a panel of judges for the AI's thinking process.
Exactly. And they're assessing, is this step a good step? Is this a bad step? And what's interesting is they found that tree search and specifically a method called rebase actually performed the best when it came to scaling performance. So even though the paper focused more on sequential thinking, parallel thinking might actually be the key to making AI even smarter.
It's definitely a possibility.
Interesting. And it kind of highlights the fact that there are multiple ways to approach this problem of improving AI reasoning.
Yeah, it's a really complex landscape, right? It's not a one-size-fits-all solution.
No. And a big part of this exploration is the dataset itself, right? The S1K dataset with all those crazy hard problems.
Yeah, that one with the human versus star question. I still don't even know. It's a tough one. Where to begin with that one. But there's a lot more to this data set than just its difficulty.
The researchers went to a lot of effort to make sure it was also really diverse and really high quality.
So, it's not just about throwing a bunch of hard problems at the AI. It's about really testing its abilities in all these different ways.
Exactly. So, they want it to be challenging, but they also wanted it to be fair.
And they wanted to really understand, what are the AI's strengths? What are its weaknesses?
Okay. So they put a lot of thought into designing this data set.
They did. Yeah, it was a huge effort. So what exactly did they do? I'm picturing, a bunch of scientists locked in a room with piles of textbooks, just coming up with the hardest problems they could think of.
Well, it wasn't quite like that, but it was a pretty big undertaking. They started with this massive pool of over 59,000 potential problems.
15. And they got these problems from all sorts of places, online forums, competition archives, even academic journals.
So, it was a really diverse set of problems to start with.
Okay, but how did they narrow it down to just 1,000?
So they had this whole featuring process. Okay, and they were guided by three main things: quality, difficulty, and diversity.
Makes sense.
So, first they want to make sure all the problems were well written.
Yeah, you don't want any trick questions.
Exactly. They wanted them to have clear solutions. Right. So the AI isn't getting tripped up by the wording.
Exactly. It's about testing its reasoning ability, not its ability to understand, tricky language.
Right. And then the next thing was difficulty. They wanted problems that would challenge even the most advanced AIs. Right? Not stuff they could solve easily.
Yeah. They wanted problems that would really make them sweat a little bit.
And then finally, they really wanted to make sure the dataset was diverse, right? Representing lots of different areas.
They wanted problems from all different fields, so they could test the AI's ability to reason across a wide range of topics.
So they weren't just testing how good the AI was at math. They were testing how well it could think in general.
Exactly. Like how adaptable is it? Can apply its reasoning skills to different domains.
It's like they were designing a mental gym for the AI, with all these different exercises to work out its brain.
That's a great way to put it. Yeah, and to make things even more challenging, they didn't just include the problems themselves.
Okay, what else?
They also collected reasoning traces for each problem.
Remember those step-by-step explanations of the thinking process.
Yeah, it's like looking at the AI's scratch paper. Exactly. But here's the interesting part. They didn't use humans to create these reasoning traces.
Okay, who did they use?
They actually used another AI system, Google's Gemini.
Wait, they used an AI to generate the thinking process for another AI.
That's right.
That's kind of wild.
It is a little bit mind-bending.
Yeah, so like AI Inception or something.
Exactly. But there was a good reason for this. They wanted to be able to generate a ton of these reasoning traces really quickly.
Which would have taken humans forever.
Makes sense. Time is money.
Yeah, and so by using Gemini, they could cover a much wider range of problems.
Okay. So they sped up the process. But how did they make sure that the AI-generated reasoning traces were actually good?
Well, they had another AI system check the work.
Oh, okay, so AI checking AI.
Exactly. They used a system called Claude to evaluate whether each reasoning trace was actually correct.
So it's like double checking the homework.
Yeah, basically.
That's pretty clever.
It is. And then to make sure everything was really top-notch, they had humans review a subset of the reasoning traces as well.
So it was a real team effort.
Yeah, humans and AI working together to create this incredible data set.
Yeah, so it really was a monumental achievement. And this S1K data set, it's like the foundation for all of this research, right? It's what allowed them to really push the boundaries of AI reasoning. And it's amazing how much work went into creating it.
It was a huge undertaking. Yeah, but I'm really curious to see how these AI systems actually performed on these problems.
Yeah, me too. And that's what we're going to dive into in the next part of our deep dive.
Okay, stay tuned. Okay, so now for the main event. How did these AI systems actually do when they had to face these super tough problems from the S1K data set?
Yeah, they really put these AI models to the test like the Mental Olympics for AI.
Exactly. And they tested them on a bunch of different benchmarks to assess different parts of their reasoning abilities.
Like a comprehensive exam?
Yeah, testing all their skills.
Cool. What kind of benchmarks did they use?
Well, one of them was the American Invitational Mathematics Exam, the AAP.
Oh, wow. I've heard of that. That's like for high school students, right?
Yeah, but it's notoriously difficult.
Yeah. Even I would struggle with those questions.
Yeah, a lot of people would. And what else? They also use something called MAT H500, which is a collection of competition math problems with different levels of difficulty. And then they also use GPQA Diamond, which is a set of like PhD level science questions.
So they really threw everything at them.
Yeah, they wanted to see what these AI models were capable of.
Okay. So how did they actually do? Did this whole budget forcing thing actually help?
Yeah, it did. They found that giving the AI more thinking time through budget forcing led to significant improvements in ACC accuracy across all the benchmarks.
Yeah, across the board. So it seems like giving them that extra time to really think things through actually made a difference.
Like giving their AI brains a little coffee break.
Yeah, exactly. But remember how we talked about that sweet spot, right? Too much thinking can be a bad thing.
Yeah, and that's what they found here too. The benefits of budget forcing eventually plateaued.
So, giving the AI unlimited thinking time did make them infinitely better.
Right, there's still limits. Exactly. And one of those limits, as we talked about before, is the AI's context window. It's short-term memory, right? I can't remember everything.
Yeah. So even if you give it all the time in the world, it can only hold so much information in its mind at once.
That makes sense.
So what about those other approaches we talked about, the parallel scaling methods, right? Majority voting and tree search.
Yeah, did those do anything?
They did. And this is where it gets really interesting. They actually found that tree search, specifically a method called rebase, performed all the other approaches.
Oh, wow. So parallel thinking might be even better than sequential thinking.
It seems that way, at least when it comes to scaling performance.
So it's like giving the AI the ability to explore multiple solutions at the same time.
Yeah, exactly. Kind of like a massive brainstorming session.
That's pretty cool.
It is. And it challenges that old idea that to make AI smarter, you just need to make the model bigger, right? Just keep adding more layers.
Yeah. This research suggests that it's not just about the size of the model. It's also about how it actually thinks, how it uses what it knows.
Exactly. And optimizing the thinking process through things like test time scaling and parallel processing can lead to huge improvements in AI reasoning.
So it's like we're moving beyond just brute force AI and into this new era of like smarter, more strategic AI.
Yeah, it's a really exciting time to be working in this field.
It is. But it also makes you think about like, what does this mean for the future?
Yeah, what happens when AI can reason as well as humans, or even better, right? What happens when AI can help us solve all sorts of problems that we've been struggling with for years?
It's a big question, and there's no easy answer. But this research gives us a glimpse into what that future might look like.
And it's a future where AI can not only solve problems, but also help us understand the world in new ways.
Yeah, and maybe even understand ourselves better too.
That's a really cool thought.
It is. Well, we've covered a lot of ground today, from budget forcing to parallel processing to the amazing S1K dataset.
Yeah, my brain is definitely full, but this is just the beginning of the journey, right? There's still so much more to explore.
Exactly. And we encourage you to check out the original research paper if you want to learn more.
Yeah, and maybe even try applying some of these AI-inspired thinking techniques to your own life.
Right. If AI can learn to think more strategically, why can't we?
That's a great question to leave us with. Thanks for joining us on the Linkffiti's Deep Dive.